I'm here to talk about Apache Kafka today. What the heck is that, right? So let's get started. In 2022, the StackOverflow survey results revealed that 34.16% of developers dreaded learning Apache Kafka. And I don't know about you, but when I have a feeling like anxiety or fear or dread, I try at least to respond with an attitude of curiosity. So why am I experiencing that feeling so I can address the root cause? There are two reasons I can think of when it comes to Apache Kafka in particular. One is that it's a new thought paradigm to start thinking about problems with. So it's as if you were an API developer who had learned to build and make requests to an API. And, all of a sudden you're learning about databases. So Apache Kafka has a new structure, and it also involves thinking about things in terms of events. So it's a new thought paradigm, and that can be a little bit intimidating at the first. The other reason that I can think might be for this dread of learning Kafka is that there is just this gorgeous depth and breadth of tools for Kafka available, kind of like there's a huge variety of ocean life, and that can be a bit daunting to navigate at first. So in this talk, we are going to address those two reasons why you might fear learning Kafka and hopefully neutralize them. So let's go. Okay, so what is it? Apache Kafka is an open source distributed event streaming platform that aims to provide a high throughput, low latency solution for handling real-time data feeds. So that's what we call a spiel, right? And we will break the terms down and get a deeper understanding of what this definition is as we progress through the talk. Before we get into what the structure behind Kafka looks like, I think it's important to discuss where Kafka is useful. So it's useful in things like event-driven applications. That is an application design where instead of making a request to see if there's an update in an object, your application is subscribed to an event, and as soon as a new event comes in, it can react to that new event. It can also be useful when it comes to designing data pipelines, stuff like mainframe conversion and website clickstream analysis, which it was used for in its original use case at LinkedIn. So today we're going to walk through the structure behind a mock app that takes in clicks, so kind of like a clickstream analysis application, and moves them into Apache Kafka, and then we'll read them out in some logs. All right, so if Kafka is event streaming, what is an event? Broadly speaking, an event is a thing that happens. Within maybe application design, you can think of an event as something like if you're writing a rideshare app, it could be that request for a ride. If you're writing, working with Internet of Things, it could be a change in the thermostat, right? If you're tracking clicks, it would be a click. So in Kafka, events are represented by a key and a value. So here the value is a click with specified as a click on a toggle, right? And then usually you're going to want a timestamp in there as well. Oops, let's go back a couple. There we go. So how do we organize events? Say you were clicking on a page and there was a toggle and a search bar and a start button, and you wanted to put all of those clicks into one group. You would organize them into a logical grouping called a topic within Kafka. Now, the underlying data structure of a topic is a log. There's a couple of things to note about logs before we move on here. One is that once an event is stored in a log, you cannot delete it and you cannot mutate it. Sometimes people with data backgrounds come to logs with the understanding that, oh, if an event is read out of a log, it disappears because it's like a queue, right? That's also not true. An event persists inside of a log in a topic, and that's useful because that means you can perform analysis on events from several different positions at once without destroying those events, right? Now, topics are split up into separate logs called partitions, and each of these partitions can live on a different server in a cluster or grouping of servers. And that is what gives Kafka its low latency, high throughput quality. How do events get into those partitions? That's the role of something called a producer. So a producer is responsible for key assignment to partitions. So usually what will happen is if your key comes in and it's not null, then the producer will perform a hash function, and then it will assign each event to a partition inside of a general topic based on the key of that event. If the key is null, it'll do like a round robin thing. Also important to note, each producer can write to multiple topics. Now, if that's how events get into topics, how are they read from topics? Consumers are subscribed to topics. They can read from many topics at once, and they can be organized in groups. Something that I wanted to point out here is that each consumer that's in a consumer group, if they're in the same group, they can't read from the same partition at once. So in this slide, consumer 1 can read from partition 1 and partition 2. Consumer 2 cannot read from those partitions. It has to read from partition 3. So that was a lot of abstract concepts. So let's get into some code. What we're going to do is we're going to implement a consumer and a producer inside a Node client. So the first thing that we're going to do is set up really these authentication details. I have a cluster of servers set up in the cloud. I'm using Confluent Cloud for that purpose. And I want to authenticate to it. So in order for the client to be able to do that, I have to give it this information. I'm using a utility file to read from it. Normally, in Node, we would use a .env file, but this is part of a multi-language suite of tutorials that was made for developers to learn Kafka in their language of choice. So, and all of them kind of use that same utility of just reading from a separate utility file. So that's why it's this way in this code. This piece of configuration right here, the dr msg cb true, what that means basically is that we'll be able to surface error messages to the client if we set it to true. So that's nice. And then to create the producer, we're going to pass in that configuration. And then this create producer function returns a promise, which resolves the producer and then also provides a delivery report and those errors that we're talking about, and then hooks up the producer. Let's move over here. I feel like I have to keep control of my mouse because it's sliding. But so here, what we're going to do is we are going to set our topic to clicks. So there's a clicks topic up in the cloud that we're connecting to. Then we have some mock data here that's going to represent our keys, and some mock data that represents the data coming in from our, say, our clickstream analysis application. So kind of like what we saw on the slides here. And then what we're going to do after we create the producer is produce random combinations of those keys and values into the topic. And we'll be able to see that once I pull up my terminal. But I just wanted to point out also this function here, the flush function, that just makes sure before I disconnect from the producer using the terminal, all of the events that get sent up, 10 events will be sent and won't get interrupted. So let's see how that works. So this is running the node file that I just walked you through. And we can see console logged a bunch of click events. So that can confirm for us that we have produced those mock events to the topic. Now, how would we know that, or how can we read those events? Let's create a consumer in the same client. So here we see a lot of the same configuration that we use to connect the producer. And then we also have a group ID. This one doesn't matter so much since we have one consumer, so it's just going to belong to its own little group. But it's important when you're setting up applications to think about, say if you had like a microservice application and you put two consumers in the same group, they couldn't read from the same partition, right? So you might want to instead use a UUID because you want those consumers to be able to read from the same partition if in your microservice architecture they needed the information from the same partition, right? So just something to think about if you get started on your own. Here's the create consumer function. I want to draw attention to this piece of configuration. Auto offset reset earliest just means that there's an offset in the consumer, and what an offset is basically like a bookmark that the broker or like the server that's in control of this information will keep track of. And if the consumer goes offline, it can return to that bookmark and keep reading it. Then we connect the consumer, and we will make sure it goes to the same clicks topic that we produced to, and we'll log what we're consuming once we consume it. So let's run that in the terminal as well. Just change this to consumer real quick. Okay, so we can see the events coming in that we produced. Some of them are from even earlier on in the topic due to that offset. And then once I produce, you can see as soon as new events are produced, the consumer is picking up on them. So that concludes the code tour. Get back to, there we go. So as we saw, as soon as I produced the events, they were consumed by that consumer. We could see it in the terminal. That leads a lot of people to refer to Kafka as a central nervous system, because Kafka is able to transfer data in real time. So as soon as I produced that click data, we could see it coming in through the consumer right away. It's kind of like if if your hand touches a hot stove, the classic like sense example, right? Your nerves are able to coordinate to move your entire arm away immediately. So hopefully that addresses the first bit of the introduction of this new thought paradigm. The other part is, how do we navigate knowing if, say, we need to build something with Kafka, we're building something that's handling a lot of data and it needs to move it very quickly in an organized way. How do we get started? What resources and tools should we use? There's a lot out there. There's Kafka Connect, there's Kafka Streams, there's KSQL DB, there's a bunch of different GUIs, at least 4 CLI tools. There's Kafka Shell Scripts, KCAT, KC Control, Confluent CLI. There's something called KIPS, which I enjoy reading, but there are Kafka improvement proposals. So Kafka's open source, and you can read the improvement proposals that engineers have created to kind of direct the future of Kafka. And that's super interesting if you're getting really into it. And then, like most technological topics, there's just a plethora of O'Reilly books about it, right? So how do you navigate this wealth of resources? I'm going to throw it back to when I was learning how to code in 2020. I don't think that was an easy year for anybody. No one's like, yeah, 2020 was my year. And for me, I was like, it's definitely no exception, right? I was recovering from a traumatic personal loss. I was dealing with some gnarly health issues, and I was juggling childcare back and forth with my husband while I was going through a coding boot camp. And all that stress meant that I really couldn't debug my way out of a paper bag. So what I did was I turned to community for help. And the particular community at that time that was helpful to me was called Virtual Coffee IO. There's going to be a link to it at the end of this talk. But the senior engineers there paired with me and showed me what kind of patterns to follow when you're debugging, but also when you're coding in general. And that really taught me a great lesson, because now whenever I'm learning something new, I go to someone who's been using it for a while and say, hey, I have this particular problem with this particular constraints, and what are the upsides and downsides of using these tools I've been considering? So I would like to direct you to some community. So there's a couple of different ways that you can engage in community. So there's if Kafka in particular, there's going to be a conference in London, Kafka Summit London, this May 16th and 17th. I'll be there. I'm really excited to meet new Kafka friends. You can also check out your local Kafka meetup. I'm going to have a link that I can put in the chat. where you can access local Kafka experts. And then there's also current 2023 that's happening in California in September, which is a big Kafka and then also like data related centered conference. Online, you can use the Confluent community Slack. We'll be happy to take your questions from small details, configuration details, to large conceptual questions. Also, there's a pretty lively Reddit thread, Apache Kafka. If you're interested in tech support in general, to get support from your community, you can always go to Virtual Coffee.io. And then also, this one is great too, Certified Fresh Events.dev. I highly recommend sticking around here. And that hopefully neutralizes the second fear for you. So let's return to that spiel. So Apache Kafka is an open source distributed event streaming platform. So we discussed what events were, that aims to provide a high throughput, low latency solution, thank you partitions, for handling real-time data feeds. And we saw how that data performed in real time when we went down and saw a code example of a producer and a consumer. I'd like to present myself as your first contact in the Kafka community. This is my professional contact info. Feel free to get in touch. I'd love to chat about it. And that concludes my talk. I'd be super happy to take any questions that came up.
Yeah, thanks. Thanks, Lucia. This was all new to me too. I mean, I've obviously done event-driven like application stuff.
Sure, yeah.
Not using Kafka. We did get one question from the audience, and I've got some questions myself. But if anybody listening has additional questions, please just put them. Part of the benefit of these showing up to these events live is being able to ask your questions of the speaker directly. So Ryan asks, have you seen any neat projects that emphasize WebSockets in Kafka? Are most front-end Kafka projects over WebSockets?
That is a really great question. I believe I have one for you. I can go.
Do you want me to share your screen again?
What's that?
Something you're going to share on the screen?
No, I mean, I don't have it right there. I need to look it up, but I believe I have something that has to do with its live data that comes in from the Norwegian Port Authority on ships. So yeah, that's something that comes in over a WebSocket. And Ryan, I will get in touch and get you that demo because it's fun.
Okay, yeah, you can if you find it, you can post it in the. If you go back to the Crowdcast or whatever, you can just post it in the chat or whatever.
Cool.
It'll be there. Yeah, that's really interesting. So in that ship example, I'm assuming this would be like the data is coming in about ships from an external system and feeding it to Kafka, and then I can be on the site that's actually reacting to that ship data in real time and maybe showing me location or
right. So yeah, this is a demo that I've been working on, and really we don't have the like front end up yet, but we will. So but yeah. That's a great question. What other questions did you have?
Yeah, so we've got more from the audience. Nick asked, at what point would you introduce Kafka into a project?
Oh, that's a great question. So one thing that I know is that Kafka it accepts like conversion pretty well. So it's that's why people use it for things like mainframe conversion. So you can slowly like incrementally introduce it in your org. So that's something. But basically, I would do it if I was handling a lot of live data. So any point where you have that, if you're using another way to handle it, then you can do a pretty a safe conversion because of the fact that those topics can persist, right? But yeah, it would depend on what, like, I wouldn't use it for like my personal website because I don't handle any type of data on there, right? So it's definitely something.
Yeah, I'm thinking like it's got to
It's
be a
actually a decision to
very
make.
specific. Like it's not just large amounts of data. I'm dealing with large amounts of data that are constantly like streaming in, like your ship example, or like if I'm tracking like kind of similar to that, like I'm doing. I know people have friends who work in industries where they're just tracking all the trucks that are delivering or doing repairs or whatever for like and that kind of data that's constantly going and streaming.
Right. If you're executing batch data and it's okay for it to come in 24 hours later from when you execute the query, then yeah. But the point is like it's when you have that real time need.
Yes. Okay.
Right. And batch data queries, they can kind of imitate real time up to a point, but they can't be as fast as like a truly real time system can be.
Right. Yeah, and I think the key here, what you showed, is that it's not just consuming the data. It's that like once I've set up that like into Kafka, but like once I've set up that consumer on my application, that's just streaming in constantly and automatically updating, right? So
right. Yeah, it's reactive instead of you having to go and make a query.
Yeah, exactly. So
just the whole design.
So Ryan had another question, which is that would you suggest every browser session is a different Kafka consumer, or is it like a single consumer per like is it like, oh, okay, I'm going to set up this piece of the application that has its own consumer? Is it a consumer per session?
Right. That is a great question. I will ask someone in my org who is familiar with like using it in browsers and get back to you.
Okay. Okay. Yeah, that is a good question. I guess I'm thinking like just offhand. Obviously, I know nothing about the like. I'm only learning what you taught me. I'm like imagining that would really depend on the nature of the data, right? Like,
yeah,
because if everybody's viewing the same thing, then it'd probably be a single consumer for all those people. But if each session has to get its own data,
yeah, then you might want to set up consumers, and you can also filter data, so those consumers could be consuming from different topics based on your user demographics and things like that.
So like, could you filter it differently for each user then? Like if you had a single consumer, but I filter it differently based on who's connecting, is that possible? Or
yeah, I mean, that consumer can consume from different topics too, but you might want to set up multiple ones depending on like how much traffic you're dealing with. It's interesting because I think this is also like the hardest part of Kafka. It's like, okay, I got it. There's producers and consumers and events, they're stored in topics. But then thinking about what you want to do with it and how that works and applying it to your concrete application. Like recently I was building like kind of like a demo microservice application, and I had made the mistake of putting them all in one consumer group. And then I was like, why are some of my consumers not getting any events when I see them being put into the topic using the tools that I was using to view the topic other than consumers? And I understood, it's like, they have to be in different groups because I was hoping to read from the same partition based on on a key, and they were all in the same group. So due to like the work sharing rule that is there, they couldn't read from the same partition.
And how do you determine like what your partition does Kafka determine what the partitions are for me, or do I tell it like, hey, these are the different partitions?
Right. So there's a default number of partitions. There's 6 of them, and then you don't, as far as I know, you do not decide specifically which partition gets which like key assignment, but there's settings on the producer that affect that. Okay. So it's also important to think about balancing your load there, because if you know that most people are going to, like, say in our example, come to a page and click on the toggle button, and that's there's going to be, and you want, or say instead of clicks, you've got clicks and clicks aways, and then you've got like other events on that screen, like arrow up and arrow down, but clicks are going to be the biggest one. You might want to think about your partitioning strategy a little bit, because you know that the partition with all of the clicks in it is going to have the most load there. And you want to make sure that your load is distributed evenly to make sure that Kafka is performing to the best of its ability.
That makes sense. Okay. Yeah. So these are kind of feels like issues I haven't, because this is like a scale of application I haven't built.
Right. Yeah.
It's like, okay, I'm like trying to imagine all of this amount of data coming in. But I mean, there are a ton of use cases that come to mind. Like, I'm thinking of like anything with transactions that need to be able to update real time and have the application react to them. Or like some of your other ones that you were talking about, tracking locations or clicks and things like that, where there's just a lot of data and you have to react to that data. Makes sense. So, one other thing. So, I just want to clarify, like topics is like the way I kind of segregate the different types of data. That it's almost like am I thinking about it right? If it's almost like this is like my table in the traditional SQL like server.
Yeah.
Like so a way of segregating different types of data. Like here's my click information data, but this is now my ship tracking data.
Right. If they're making clicks to make a request, maybe you want to keep the request information in a different topic, right? Because one part of your application is analyzing user clicks. The other part might be tracking the requests that are being made for keeping the transactions, like what they are, like transactions, so that there's no repeats or dupes.
Okay, that makes sense. Totally. All right. Well, I didn't see any other questions from the audience, but I'm like trying to think, what can I build using this? Some fun.
There's you can use GitHub as a source connector, so that commits and things like that become events.
That's interesting.
One thing that might be fun. I'll put a link to. I'm going to move it over. This link might change orgs, but I will put this demo in.
I'm going to share some of those links that you shared about community stuff in the chat as well. Okay. Let me share that demo. That's an interesting set of data. I'm like thinking, another one would be, I think, any kind of like if you're tracking data coming in through any kind of social channel that you're reading from the APIs, that maybe you're kind of consolidating a bunch of social stuff to run updates on your application, would be something that has a lot of things coming in and you want to be able to be reactive to.
Yeah, like LinkedIn.
Yeah, like LinkedIn, of course. Yeah, who created Kafka? There, now it's all comes together.
Yeah, there you go. I think that brought it down.
Okay.